So the topic we're looking at here is specific heat, but there's really three things I want to introduce in this topic. In the key concept slide, the formulas are here for specific heat, heat capacity, and then this is specific heat in terms of heat capacity. The concept of heat capacity is really the more basic thing. And before I even talk about the formula for that, Q over delta T, it's probably important for me to say that this symbol Q that I've introduced here really is going to be the symbol for the amount of heat that we're talking about. So usually that's a process, right? Something is being heated. But Q is going to symbolize the amount of thermal energy transfer that heating represents. And so heat capacity is a characteristic of an object. If I have, say, a frying pan, that frying pan will have a certain amount of heat capacity associated with it. And what that heat capacity tells me about is how much heat would I need to raise it a certain temperature. So if I want to raise that frying pan by 10 degrees Celsius, then I would take 10 degrees Celsius, multiply by its heat capacity, and that would give me the total heat needed. And so the definition that aligns with that is that heat capacity is the amount of heat needed per temperature. That means if it's heat per temperature multiplied by temperature change, that gives you the amount of heat. So if somebody lists that and says, here's the heat capacity in maybe joules per degree Celsius, one could also use joules per Kelvin, since the degree Celsius and the Kelvin represent the same incremental change, and maybe using the Kelvin is the more SI thing to do. But that's how heat capacity would work. Now, just like though, like why do we need something like specific heat, right? So one way of putting it is like, if I look at an object and I might say that object has a certain amount of mass, but then if I say, okay, but the object is made out of aluminum, and then I could say, okay, well, maybe there is this much mass of aluminum there, but I could also say, well, aluminum has a density, and it doesn't really matter what object I've constructed out of aluminum, it will have the same density regardless of the object. So specific heat is like that. Aluminum will have a certain value for its specific heat. And so would things like maybe cast iron, copper, etc., other materials. So this is more associated with the type of material we're talking about. And similar to how density is mass per volume, maybe I don't know if this is quite as similar as I just said, but specific heat is actually like heat capacity. Rather than per volume, it's per amount of matter. So it's like heat capacity per mass. What that means is if I say I've got a frying pan, it's made out of, let's say, aluminum, and then I tell you the amount of mass that aluminum represents. If I want to find the amount of heat to raise it by, say, 10 degrees Celsius, I would multiply by the amount of mass of aluminum and then also multiply by the specific heat. That's actually what this formula down here says. This is possibly the simplest formula to remember when it comes to specific heat, and it's basically the same as this first formula on the key concepts page. I've just multiplied through by mass and change in temperature. The reason to have, though, both the concept of specific heat and heat capacity is because just like for the purpose of motion, like if I say, hey, I've got an object and I want to start from rest and accelerate to this speed, how much force am I going to have to apply for how long? And by the way, it's made out of copper, and that's all I'm telling you. Well, that means you can look up its density, but that wouldn't tell you enough information. You really need its mass to answer that question, right? So you'd have to say, well, how much copper, right? Or give me the volume at least so I can multiply that by density and find out how much. And in the same way, since heat capacity tells you how much heat would be needed to raise an object by a certain temperature, it is maybe analogous to mass, and specific heat is more analogous to density. So they both have their place. I tend to use heat capacity more at a conceptual level, and specific heat tends to be a little bit more useful when you're doing mathematical kinds of problems and answering those types of questions.